In this question, we are to write a function that represents the result of the transformation. So we're starting off with a function labeled f1 of x, and then we have a verbal description here of how we need to transform it, and we need to come up with that function. So I'm going to start off by writing an equation here on my right side. This is going to help me come up with my functions that describe this transformation that's happening. I'm also going to write down or draw in the parent function of an exponential function, which is what f1 of x is. Now back to my equation here. H is the variable that controls how far my graph is shifted to the left and to the right. And then my variable k is going to represent my shifts up and down. Now here's a disclaimer. If we want to shift our graph to the left, we need our h value to be negative. And if we want our graph to shift to the right, it has to be positive. If we want it to shift up, we need our k value to be positive. And if we want to shift down, our k value has to be negative. So when we write f2 of x, which is going to be our new function here, it looks like we need to shift it to the left 2 units. So I'm going to start off by writing my base of 2, and then in my exponent I'm going to have x, and then we're subtracting 2, and we want it to go to the left, so our h value is going to be negative 2. So we've got that. And then we want it to move down 3 times. So whenever we move down, our k value has to be negative. So then we plug in a negative for our k, and that's going to be 3. Okay, we can clean this up right here. So I'm going to rewrite this. It's going to say f2 of x equals 2, and then whenever we subtract a negative number, we could just change that to addition. So this is going to be our final function right here, f2 of x. Could you have just jumped right to the plus 2? Sure, because in our formula here we're subtracting h, so we're doing the opposite of h. So like I said, our h had to be a negative 2, so we go opposite, which would be plus 2. Part B is a little bit harder than part A, and that's because in part B our starting function, which is f1 of x, isn't our parent function. So I'm going to have to create our new function starting with y equals, going off some of the information that we have right here. Okay, so the first thing that my new function is going to have is a transformation to the right. It's going to be shifting to the right 2 units. Okay, so now where are we starting off here? Well, we know that our h value, which shifts our graph to the left and to the right, is going to be affected up here in our exponent. And whenever we're subtracting a positive number, so whenever our h is positive, we're shifting to the right. Well, if we need to shift 2 more units to the right, we're no longer just subtracting 2. We want to go 2 more units, so we have to go x minus 4, because an original shift from the parent function of 2 and then 2 more is going to end up giving us a minus 4. So our base is going to be 3, and that's okay. That's a little bit different than our parent function, which had a base of 2. It just means our graph is increasing a little bit quicker. But back to here, this is going to say x minus 4. And that's going to reflect our shift to the right 2 more from this original shift of 2 from our parent function. And then it says that we have to shift up 5 units. Well, looking at this equation here, it looks like we went down 4 units. So we want to add 5 to this negative 4. So if we have negative 4 and we add 5 to it, we're left with a positive 1. So in my equation, I'm not going to say plus 5, I'm just going to say plus 1, because I have to make up for that minus 4 that was in f1 of x. Okay, so if I box this up, this is going to represent my new equation that takes into account this transformation.